Welcome to Circuit Analysis. We've got a new bolt version out, so we're going to go over the updated features. So here we are. So now instead of just dragging and dropping parts, you can select them and then have this shadow where you can rotate, and then H, so R to rotate, H to flip horizontal, V to flip vertically. Place as many of them as you want. So you can select different parts here, select it again for unselecting, or you can hit escape to get back. You can select a bunch of parts, and when you Control C, Control V, then that gives you the placement shadow as well. There's also, we'll Control Z, undo that. To make a part now, any part can be a single part or it can be a schematic part. And if you right click on a library with a selection, you can say from selection. I'm just going to put test, and that creates a new schematic part here. And you can click on that, you can place the whole thing. So the library has been updated. You can right click on parts now and click delete. You can drag them to different locations to relocate them. Get rid of that one. So the parts now show the names next to them. You can right click here. You can show or hide names. So editing the parts, now you can right click on them and do edit. This brings up a whole new schematic. And on here you can right click, and that's where you can load a different image, or you have settings here. So now there's some new settings that lets you change the width and the height directly without editing the JSON object. And then you have different pins here, and you can click in these pins when you're adding the pins to the symbol, and you can type a number, or you can just hit the arrow keys, and that moves the pins around so you can get them all in the right spot. And then you set up your properties and your definitions down here. So every part is basically a schematic now, so you can add multiple symbols or whatever you want to it. If you want to copy a part, you can right click and you can copy it. Once you have one copied, you can right click on another library and do paste, and that way, see, it pastes it down here. Now I added this new library for Christoph Basso's power electronics stuff. These are models from some of his books, including Switch Mode Power Supplies, Spice Simulations, and Practical Designs. I added a new example of a flyback converter, so you can go to File, Open, check out the examples here. Flyback converter closed loop. So this here is using Christoph Basso's switching model right here, this PWM CM2, and that is attached using this subcircuit. So you have the pins that you can move around and everything. Now basically every part can be a subcircuit, but this is a special generator one that you can resize and you can add pins to and move the pins around. So pretty easily. So if you right click, you go settings, so you can add pins to it like that, drag them around, and let's see. So here we have all the properties for this, and you can see it's got a couple of definitions. So I've added a text definition and a schematic. So if you click on this with the left click, you can select which type it is, a direct or a subcircuit, schematic, or text. So if you do direct, it just puts it straight into the netlist. If you do subcircuit, it uses a subcircuit wrapper in the netlist. So we have it as a subcircuit. If you double click anywhere on the schematic or you right click, you can do the netlist here. And you can see, so we've got right here is the subcircuit PWM CM2 that's being generated. So you can double click in here, and now this opens up. Because it's a subcircuit, it opens up the symbols inside of it, and then inside here you can tree in now as many layers as you want. So you go into this. This one is a text-based one. This air ramp, this is another symbol-based subcircuit. So you can see all the parts in here. Now you can see this feeds back through here. This is like representing a PWM chip that has the air ramp inside of it. So this is the compensation in here. This is the current sense resistor here coming back to the current control. So when you go in here, this is the air ramp inside of the chip right there. So now we can run this. And here we have the output, so it starts up and it settles at 12 volts. You can see it overshoots a little bit here. Now we also have settings on the schematic itself now. So if you right click in a blank spot and you do settings, this shows the path, the description, all the parts in the schematic, and then all the subcircuits. So this is kind of cool because you can rename and move the subcircuits around. So the way that it works is subcircuits are global, basically in SPICE. So structurally, they all show up here at the top level. And if you want to make duplicates with different parameters, you have to copy them and give them different names. So the other thing is multiple configurations now. So you can add configurations up here. And then when you click on the radio button, you switch to the other configuration. So here I have a linearized configuration. So each configuration is its own separate schematic, and this one is a linearized version of the previous one. So it's got Christoph Basso's PWM current mode model here, and that does not have the error ramp inside of it. So we have the external error ramp here. Here's the compensation, and this is just the output of the duty cycle, and everything else is kind of the same. The switch and the diode are inside here, linearized. So we're just getting the average response, ignoring the switching waveforms. So this allows us to run an AC analysis and plot the Bode plots. And this makes it real easy to adjust the compensation. So you can take this and do like C, if you want to look at 100, run that again, and you can see how it changes. So then you can take this and go back to the other one, and you can tweak the compensation here based on what you learned from the Bode plots. So that's it for today. Let me know what you think. We've got the comment section down below, and then the Discord channel I'll put in the description. If you got any feature requests, I'm thinking maybe some Python integration, some more linearized models, more examples of power converters, and maybe magnetics, a generator kind of part, and some more library parts. Anyway, thanks for watching, and I'll see you next time.